When TIG welding, it can be hard to know where to get started or in which order to apply the critical steps to achieve the best results. With this in mind, we've broken the job down into a simple 6-step process that will ensure you get the right results with the minimum effort. This will also make sure you don't overlook any critical steps that could waste time or even resulting in something needing to be completely redone from scratch. We're going to cover the simple 6-step process in the following set of modules, and the first step is to prepare our material for the welding process. It's really important to understand that a good TIG weld starts well before picking up the torch and switching on the machine. This can be an easy thing to overlook, especially when you're eager to get straight into laying some beads. Generally, all materials go through a rigorous manufacturing process, which means that by the time you get a hold of it, it may be oiled, painted, or wrapped to protect against the elements in transport and the storage phase. It's a good idea to leave these oils or wrapping on the materials if you plan on storing them for longer periods of time to limit any rust or oxidization forming. When it comes time to weld, you're going to need to remove these protections completely, regardless of the type of metal you're working with. But for now, it's just important to give it all a wipe down with a rag before handling and cutting anything to length. This is going to eliminate any oils being introduced into the metal and improve the overall cleanliness of your metal preparation. One thing that all metals will have in common is that they need to fit properly to achieve a consistent, high-quality TIG weld. Now, what I'm talking about here is the fit-up between the two pieces of material you're about to weld. While MIG welding gives us the ability to bridge some quite significant gaps between the pieces of material we're welding, this isn't the case when we're TIG welding, and the better our fit-up, the better the finished weld will be. Taking a little extra time to fit your metal into position with a minimal gap will make the TIG welding process a lot easier. Larger gaps will require longer welds and more filler rod, which increases the amount of heat in the part and generally looks unsightly. The way we cut and prepare our material for TIG welding can also have an effect on our weld results. Introducing oils and contaminants into the material through cutting methods, for example, can make welding a nightmare. Tools like angle grinders or chop saws that use high-speed abrasive cut-off wheels can embed particles in the cut area. If these aren't cleaned up using low-speed material removal, like a hand file, they can contaminate the weld area and lead to ugly or weak welds. Contamination can also be introduced into the metal by using cutting fluids that contain oils and chemicals. I prefer to use a cutting wax on a slow-speed cold saw, and even this still requires cleaning with acetone before welding. If we're working with tubing, it's important that we also pay close attention to the internal surfaces of the tube. If there's oils or contaminants inside, the welding process can emit dangerous levels of smoke, and that can be a real problem when you're working in confined areas like the interior of a race car. A quick wipe with a rag and some acetone will eliminate the majority of oils and reduce the danger. All metals will produce an oxide. This means rust on ferrous metals or an invisible film on non-ferrous metals like titanium and aluminium. Removing this oxide is essential in TIG welding, and the same can be said for any paint, plating, like chrome, zinc or anodizing, as well as a mill scale on hot rolled material. The general rule of TIG welding is to remove any coatings and return the material back to its raw, shiny surface. Using high-speed methods like abrasive discs on angle grinders can be counterproductive because they can burnish the surface of the material. This can impregnate the oxides under the shiny surface, only to have them come back out during the welding process. Instead, use slow-speed methods like a stainless steel wire brush, Scotch-Brite abrasive hand pads, or sandpaper, followed by a wipe with acetone and a clean rag. By having a well-prepared and clean workpiece, you're going to find the setup, settings, and welding processes that we're getting into next significantly easier to manage. Even with the right settings and techniques, welding unprepared material can be a nightmare, and putting in the effort to get this step right will ultimately save you time and improve your results and confidence with TIG welding. That was just one module from our practical TIG welding course. If you want to learn more about TIG welding, or you're looking to apply it to your car or motorcycle, then this course will be perfect for you. It will give you a greater understanding of the machines, settings, material preparation, and TIG welding techniques used in motorsport to turn your ideas into a reality. We run you through a 6-step TIG welding guide as well as our material-specific guides that will remove the guesswork out of the TIG welding process. This course is perfect for anyone looking to get into TIG welding and will fast-track you and your projects, saving you time and money in the process. Click the link in the description to get started. Thanks for watching, and remember, if you like that, then let us know by giving us a thumbs up, and also if you haven't already, then subscribe because we'll be coming out with plenty of general fabrication tips and tricks here at ETS Fab.